So we're going to start with statistics, but I'm going to break it up into two parts. The first one, what I want you to do in your notes, I just want you to write statistics and then put dash correlational studies because we're going to focus on the stats with that. Okay, so that will be your title. Then we're going to move on in which scatter plots. Okay, so that could be your subtopic, your first subtopic. And then scatter plots are basically the way that you're going to graph two variables, okay, in a correlational study. So you're just basically, this is how we do it, and it does not look like the little line. I'm going to show you guys what it looks like. It looks something like this, the little dots, right? So those little dots actually represent the value of each of the two variables that they're measuring, okay? And so obviously if it looks something like this, right, it's a perfect correlation. It's straight in that one, okay? And we'll look at more of the numbers when it comes to our correlational studies. And then this obviously will be no relationship because there's the variables, nothing is happening when one other variable is presented, okay? And so the way that we do this is a correlational coefficient. So this is your next subtopic, and this is one of the most important when it comes to correlational studies. So for correlational coefficient, it's R equals, and then they'll give you a number. Okay, so we've talked about, and the best way to define or look at this is drawing a number line. Okay, so if you draw a number line, and here is 0 in the middle, and here you have negative 1.0, another 0 there, and then here would be positive 1.00. And I want to make sure that you guys make that number line so that you know what the numbers we're going to be focusing on, okay? So correlational coefficient is basically when it's the statistical measure of the relationship, right? Because remember, correlation is testing the relationship between the two variables. And you may want to write that definition because this is a statistical number that there was a way, there's a formula to get this number. Luckily for you guys, you do not need to do that. If you're getting into stats, then you would have to figure out how to get the correlational coefficient and then to graph it. Okay, lucky for you guys, we don't have to do that. You just need to be able to read it. Okay, so this is always good. I want you guys to actually draw this, right? You're going to put correlational coefficient with the arrow to the R, right? R equals, which is your correlation, and then they're going to give you a number. So this right here basically tells you, and I want you to, put a plus sign. Then I want you to write an arrow, and then you just need to put, it's going to indicate if, and write this down, it indicates if the relationship is positive or negative. That's it. Don't write all of this. Oh, there we go. I want you to write what I just said. So indicate the type of relationship from positive or negative. So obviously this would be a positive correlation. That means if one is going up, one variable is going up, the other one is also going up. Okay, and then this basically tells you how strong it is. They're giving you a number, okay, that they calculated some way. We don't need to worry about that. Okay, but it just tells you how strong it is. Now, the closer it is, and this thing loves to change itself. Don't know why. I'm not pressing anything. Go figure, now it's not going anywhere. Okay, so here, hold on, let me see if I could pause. Guess not. It's okay. All right, anyway, this is just going to tell you how strong it is. Now, from here, and I want you to make sure that you write this number, okay, 0 in your notes. So you're going to put 0.00 equals no correlation, okay? So there's no correlation if my correlation coefficient is 0, 0.0, right? So this is no correlation, right? I'll just put C just for the sake of that. Now, the closer the number is to anything from -1 to +1 means it is a strong relationship, Okay, so it's like perfect, right? Over here, same thing. It doesn't matter that it's a negative. It's basically the negative and the positive is just telling you the relationship, okay? So make sure that you're writing this down in here, especially the number line, that you are writing here in zero, that there is no correlation, okay? And then at the two extremes, right, the negative right over here and the positive one, those are strong correlations. So if you get a number like this, right, you would have to read it, be able to say, okay, this is a positive correlation, okay? It's positive. So what I want you to do in your notes, write this number down. Make sure you have this number here. Oops, sorry. It's very difficult to type and write this with a mouse. I want you to write this number and then what it means. So this is positive. There's a positive correlation. And then I'm going to look at here and decide where does it land in my number line. Okay, so it'll be somewhere around here at about point 37. And the best way that I just remember is like a dollar. Think of a dollar. So if it's 25, a quarter, 50 cents, 75, I think of it like quarters. And then obviously the closer I am to the dollar, then the stronger it is, right? The stronger the relationship is. Now here it's a 0.37 positive on this side. So I would say there is some form of correlation because it's not at zero, but the relationship is not strong. So it's a weak relationship. So the two variables have a weak relationship, and then obviously, and then that's it. You would have to just be able to determine, is it weak or is it strong? Usually, if they're asking if it's a strong or a weaker, it'll be at, and I'll show you the next slide, which will have like the number ranges, okay? Now, let me go right over here. So see, this is what I want you to write in your notebook. Please make sure to have this as well as the graphs. This is going to be important. It's going to help you. So if I look at something like this, right? So here it says if it's plus or negative 0.70 through 1, right? Negative or positive, that means it's going to be strong. You got to know these numbers because they can't give you any of these, right? So then this would be moderate. So for the other one, I could have put moderate relationship, okay? And then, or weaker, it's okay too, because it's like in that cusp. And then here, 0.00 to 0.29, it would be either none if it's at zero or weak, okay? So good to have this down and have this little chart, as well as you're gonna have to be able to read something like this. So if they give you a scatter plot that looks like this, and you're gonna wanna draw this out, okay? And then it has R, which is correlation coefficient, equals 0, means there is no correlation at all. Okay, and you could write that there. Now, this one, right, it looks a little bit more like, I guess it's saying it's a negative, it's going this way, but you see that the scatter plots are not close enough. So this would be a moderate, okay, moderate negative correlation. And then we have this one, which would be a positive, okay? And it's a positive, and it would be, and let me see if I could just type maybe easier, but I have not that option. It's okay. Anyway, this would be positive, and it would be moderate, okay? And then this one is a negative, and this one, as you see, they're closer together. So that means it will be a strong correlation, okay? And it's strong. And then this last two, as you'll see, you see how the stronger they are, that means the variables are responding to each other. So you want this. So this would be a positive, strong correlation, this last one. And this one would be a negative, strong correlation, okay? Okay, so now still under correlation coefficient, I want you to write another example, okay? And I want you to put which is a stronger correlation, right? This is going to be your example in your notebook. And then I want you to, let me erase that, get it out of the way. Okay, and then I want you to write these numbers. So this would be negative 0.13, okay, or positive 0.38, okay, and then the strong one is going to be positive 0.38, okay. Same thing, this is a negative correlation with the correlation coefficient is 0.72 or 0.59. So which one is closer to the 1? And that one would be negative 0.72 because it's closer to that negative 1. So it doesn't matter if it's negative or positive. If it's closer to 1, then that's going to be a strong. So this is a strong negative correlation. This is a positive moderate correlation. Okay. And then here we have negative 0.91 or positive 0.04, whichever one is closer to the 1, then that's the answer, right? So it'll be this one, negative 0.91, which makes it a strong negative correlation, sorry. And this obviously would be a very weak positive correlation, okay? So these are just good examples. You need to be able to, oops, it went away, be able to read this, write it out. We'll do a lot of practice in the classroom, so don't worry about that, okay? Okay, so here's another example. I also want you to write under correlation coefficient, which is the study of low self-esteem and depression. So the two variables that they're studying are going to be low self-esteem and depression. Okay, so they're comparing the two variables. One is going to be the score of a self-esteem test, and then variable is going to be the length that they've had the depression, okay? So if you notice this variable one, which is the score, this is how we are going to measure, right? So believe it or not, if I turn this into a experimental, this becomes my dependent variable, how I'm going to research it or how I'm going to measure it, okay? And then the variable 2 becomes the independent variable, okay? So here is what it will look like, okay? Once they collect the data, this is my scatter plot for, and I'm measuring the length of the depression, right? And this is their score on their self-esteem. Now, if you notice, as this is getting higher, right, these scatter plots are getting lower. So this would be a negative, right, correlation. And if I look at these scatter plots, are they near each other? They are, which I'm here waiting for you guys to respond, but you're not even there. Anyway, but they are really close together, especially with this line. So that means there is a strong relationship between these two things, okay? So obviously, if I look at this, let me just finish writing relationships. Please, I hope you understand it. I know it's like, okay. So how do I read this? If they tell me, okay, what is the conclusion of this graph, which is exactly what they can tell you, okay? And you are going to write that there is, and let me do this because it might be easier. So here would be how you translate the graph. Okay, so this is basically, and I want to make sure you write this down. So it would be there is a negative, one second. Okay, sorry about that. So this, if I'm looking at here, there is a negative relationship. I'm sorry, negative correlation. Oh my goodness. Between the length of time having depression and their scores on the self-esteem test. Oops. Okay, so there's a negative correlation between the length of time having depression and then their scores. Then you'd have to explain that as the length of time with depression increases, then their score on a self-esteem test will decrease, right? It's gonna get lower the more time they have depression. Okay, so that would be, and then you would just have to say, you could also say there is a strong relationship between having depression and or the time having depression with the score on the self-esteem. Now, one very key thing you need to remember about when it comes to these correlational studies is that correlation is not causation. So this does not mean that if you have depression for a long period of time, that you're going to have a low score on your self-esteem. Now, there's a strong relationship, but depression or time with depression does not cause your score of self-esteem to decrease, right? The only way I could prove that is with an experimental study. So just remember that because that is key here. And you always want to make sure that you are writing that though there is a relationship, though, and write that down, though there is a relationship or a strong relationship between depression and self-esteem, depression does not cause low self-esteem. Okay, so keep that in mind because, like we've said, correlation is not causation. Okay, and so this is a good way to kind of end this little section, which is basically that correlation is not causation again. So low, because these two variables intertwine with one another, right? So if you have low self-esteem, it could cause depression, but depression could cause low self-esteem. So we don't know, right, what like one or the other does not, it's not a cause and effect. The only way, again, that I could do that is through an experiment. This is just telling me that there is a relationship between these two variables, and that is it. Okay, so it's not, and many times this is a problem that they'll get a correlational study and they're like, oh my gosh, if I'm depressed, then I must have low self-esteem, or if I have low self-esteem, I must have depression. And that's not necessarily the case. There is a relationship between them. They do interact, but it does not mean that one causes the other or vice versa. Okay, and that is it for statistics part 1 with just correlational studies. I'm going to go into the next part of stats that has to do more with the experimental and that type of data. All right, see you then.